Hello there, it's VA. Alright, I hope you enjoy you look forward to hearing my voice as well as enjoy the rest of the lesson. The background where I'm recording this is a little bit noisy, so if you do hear some banging or drilling, please pardon that. Just focus on my voice and the visuals in front of you, okay? So hello again, young engineers. Right, yes, I'm referring to you there. Remember, weren't you the ones who rescued the prince and princess when they were shipwrecked? I saw the models of the boat that you built last term. They were fantastic. Alright? And because of what you have done, we built a really impressive boat and we brought them back to the mainland. You used the property of materials to build a boat that could float and brought them back safely. Great job. Amazing. Now, the story about the prince and princess and the faithful engineers continue. Yes, that's right. Now, after returning to their castle, they got married. Of course, they were married, right? They returned to their castle and they gave birth to a handsome boy called George. Yep. George is this one. No, not this. This is Prince Harry. This is George. Yes. And very soon, 4 years has passed and it's almost going to be his 4th birthday. Now, Prince Harry is thinking, scratching his head, what present should I get for my young George? What should I get for him? So he wanted his trustworthy engineers, yes, he's referring to you there, to make a fun and safe magnetic toy for George's birthday. A magnetic toy. Now what on earth is a magnetic toy? Well, that's why we're here today. Now he hopes his engineers can use what they have learned before about materials, and together with what they will learn this term about magnets to be a toy for George. So these are just some examples of what toys can be like, but I'm sure you're more creative than all this. Now, are you ready, young engineers, to learn so you can make the magnetic toy, which you will start working on it from today? Great, I do hear a yes from inside your heart. If you're ready, let's get started. So what did you learn yesterday? You learned about magnets when you watched the slides and did all the activities online. You may have learned what they are made of. You could have learned what they do. You could learn how they behave beside other magnets or how they behave beside other materials. Like I hope you did the online experiment in BBC by moving the magnets over to the rubber ducky or to the paper clip or to anything else. If you have not done so, don't worry. Just go back and do the lesson again. And you might have learned where you can find magnets. Now, and there will be new words every time you learn new things. And words are powerful things. So by the end of this term, you will learn some new words. You will learn what is a magnet. You will learn the word iron. You will learn steel, attract or pull, repel or push, pose, like pose, unlike pose. You also learn all these words on the right hand side: north pole, south pole, north-south direction, magnetize, electrical method, stroking method. But today, we are just going to focus on these words on the left. Okay? Great. So what are magnets? Now, magnets can be found naturally. I know many of you were thinking of bar magnet or U-shaped magnet, but magnets are actually found naturally, and these are what we call lodestones, naturally occurring magnets that can be found in the ground. But it's not very useful in this shape like this. So what happened was the first person who actually made use of that material and the properties built this thing called a compass. And the first compass was invented as a device for divination as early as the Chinese Han Dynasty. That was many thousand years ago. Alright, that was about 2,200 years ago. And the compass was used in the Song Dynasty in China by their soldiers and military for navigational orienteering. Means to try to move to the different direction, and they could move to the right direction using this compass. Look at the needle and all these characters here. And they was used for maritime, this means ocean, navigation in this period of time. That was about 1,000 years ago. Alright, so this picture is not very clear. This shows a picture of a person, a sailor, a captain using a compass to navigate. But those are not very useful. That's not a very useful shape for a magnet, a lodestone. So in today's world, we try to make magnets into different shapes. Some of them are shaped like a U-shaped magnet, so its name is called U-shaped magnet. The most common one is what we call a bar magnet. They are also horseshoe magnet. Don't confuse between the two. Alright, this part is narrower, this side is wider. This part is all uniformly wide. Alright, there are button magnets, there are rod magnets, and ring magnets. And they have different shapes and sizes, different shapes so they can serve different functions. Right, used in different places. Now let's recognize the different parts of a magnet so we know what we're talking about. Let's use a very simple bar magnet. Now very often there are two colors, the blue and the red. And the red typically means the North Pole. Sometimes you see the letter N there, and N represents North. And the South Pole is represented by the letter S. So in some bar magnets, the S and N will not be printed on it. But just remember, North will be red and South will be blue. And this part is just the middle of the magnet. We will talk more about it when we do our experiments next week. Now let's take a look at another magnet, a U-shaped magnet, like the North again, the red color portion. The letter N here is a North Pole. This part is a North Pole. Notice I'm pointing to the end of it, not this portion, alright? I'm pointing to this part of it. And this end of it is called the South Pole, right at this end. So we go back to the previous slide. At this end is where I'll refer to as North Pole. Not this part, although it's red, but this part is a North Pole. And this part at this end, right at the end of it, is called the South Pole. Right, and of course the South Pole will be at this end, and the middle of the magnet is here. There are no poles here at the middle of the magnet. But what about for other magnets? Where are the North and South Pole for the ring magnet or the button magnet? Aren't you curious? Let's find out on your own at home. What can magnets do? Well, you put magnets together like this. If you observe the poles, pardon the noise in the background. Okay guys, let's focus on my voice. South Pole, North Pole. When you put these opposite poles together, sometimes they call it unlike poles. They will attract each other. They will pull towards each other. If you put the same poles facing each other, or we call the like poles, then they will repel each other. Repel also means push. They'll push each other away. Now, you cannot see this. It's like magic. But it's not magic. This is called a magnetic field and it's invisible. These lines are just drawn for you to see. That's why I talked to you earlier. Right, earlier on I said that the poles is where the end of the magnet is. You see many lines coming up from this. Okay? Now, next. And don't you think magnets are awesome so far? Yes, so much awesomeness. Let's carry on. So what are magnets made of? Well, we call these materials that magnets are made of called magnetic materials. They're made of materials like metals like nickel, cobalt, steel, iron. Alright? So these are some materials you must just remember and just know. But eventually just need to learn two, iron and steel. Okay? Now, if you put magnets beside this material like paper or glass, plastic, rubber or wood, there will be no interaction. But don't trust what Mr. Long said. Next week when I pass you the magnets and different materials, you will try it out on your own. Isn't that better? Where can you find magnets at home? You can find them probably at the door. Later when you leave the science lab, observe where are the magnetic door stoppers on the doors. Alright, this will help to attract this together. The magnet is here and here, it's attracted to each other, and then that holds the door in place. And if you have a refrigerator door, there are actually magnets inside here. That is why when you close the fridge door, the door stays closed because there's attraction between the magnet and the metal surface, which is either made of steel or iron. Now that you have all the knowledge you need to begin thinking about and designing a magnetic toy, we're going to start working on it. Now this is not all the things about magnets, but you know enough now to start thinking about making your magnetic toy. You learn words like pulse, like attract, like repel, like push, like pull. Right? You know what magnets are, how they look like. Right? When eventually you design your magnetic toy and tell us what you need, we will provide you with the magnets that you need. As many as we can provide you. Isn't that great? Now, before I proceed, let's go through our thinking cycle. This is called our project-based learning cycle. What you have been given is a challenging problem. And the problem is, design a safe and fun magnetic toy for a 4-year-old boy. Alright? This must make sure that he doesn't put it inside his mouth and swallow it. That will be dangerous. Or doesn't stuck it inside his nostrils or inside his ears. Ew, that will be very painful, isn't it? Alright, so that is a problem, but yet it must be fun for the boy. It must be interactive and must be engaging. So it's up to you to design a toy that meets all these challenges. Alright, today you're going to start working on applying the knowledge. You may not discuss yet, but you start thinking about the design of your toy. You can do some research on the computer, search the internet for different kind of magnetic toys, and think about how you will want to make it. What will you use to make it? And while you're doing all this, you must always go back to your scientific knowledge and understanding and practices. What knowledge must you use? What understanding must you have? Knowledge about materials and how they interact with each other. Knowledge about magnets and how they interact, how they repel or pull each other, or how they interact with different materials. Use this knowledge, think about the problem, and start designing something that you think is fun for a child. So what I'm going to do today is to do your own online research to find ideas on how magnetic toys can be like. You can either make those that you have found because you really like them, or even better still, you work on improving those that you like so it can become even more awesome. Remember the condition, it must be safe and fun. Now at this point, I must remind you, I saw that many of you actually logged in yesterday to do the online work. That is fantastic. Now, for the few of you who have not finished it, alright, Amar, I noticed that your work was partly completed and a few others had difficulty logging in. I would like these pupils who have not finished yesterday's work to work on it first, alright? Work on yesterday's lesson first before you start researching on a magnetic toy. Okay? Very good. For those who have finished yesterday's lesson, then you work on today's lesson. And then, don't forget what you have researched on. Your homework will be when you go home, you're going to take out your learning log, your science journal, design, sketch it out, and label your magnetic toy. You need it for next week's project-based learning lesson. Alright? And you need to find the answer to this, 3 questions, not 32 questions. Oh dear, too many. Question 1. Are all metals magnetic materials? Right? Are all metals magnetic materials? Question 2. Do you think the size of the magnet affects how strong it is? Does it mean a bigger magnet is stronger and a smaller magnet is weaker? And the third question, how differently is the word strong used to describe magnets compared to how it was used to describe materials when you were learning about materials in term 2? So these are the 3 homework. I'd like you to write down the answers of these 3 things inside your learning log. Copy down the questions and the answer, and you must have this diagram. When I see you next Wednesday, alright, I'll expect you to have answers to all these 3 questions. Or when I see you for next week's project-based learning lesson, please have all these answers ready. Alright? Great job everyone on focusing on the lesson. Now, let's get started.